Hiya. It just seems like everyone loves integration. So here I am back again with another integration question. This one, in case you couldn't tell, is from Hong Kong. Let's get cracking, shall we? Part A. Do note that the mark allocation here is a lot more rough than what you would get on the IB exam. This is just differences in the way exams are written. So these four parts combined would easily be your section B question. So 17 marks, give or take. Part A. Proving this identity should be pretty straightforward. Where do we start? Hmm. I am going to start this with two cos squared minus 1, and we shall see what happens. We can now divide both the top and the bottom by cosine squared. Now, what I think of that? That is because 1 over cos is secant. And this will conveniently gives us our final answer. Part B. Taking the hint from Part A, Part B should be quite straightforward. Why did I say that? Because we could already sniff a substitution in the background. The derivative of tan of x is secant squared. So, would it be nice if we can rewrite the denominator in terms of tangent squared? Secant squared is tangent squared plus 1. So now we can use the substitution. When you change variables, do not forget to change the bounds. So this becomes the integral from 0 to 1 of 3 plus u squared. 1 over 3 plus u squared du. This should ring a bell. This is the integral of arctan of something. How do we know what that something is? I'm going to factor the 3 out. So inside you have 1 plus u squared divided by 3. Now we can use another substitution maybe. So if a is u divided by root 3, dA is 1 over root 3 du. This integral now becomes the integral from 0 to 1 over root 3 of 1 by 3 times 1 divided by 1 plus a squared times root 3 dA. So, simplifying off the constants, recognizing the integral of this guy is arctan, and then plug in the bounds. Arctan of 1 over root 3. This is pi by 6. So, final answer, root 3 by 18 times pi. First two parts, not too bad yet. Part C. Let f be a continuous function, of course, such that this is true, in other words, an odd function. Prove that this integral is equal to the integral from 0 to a of x f of x dx. Interesting. Okay. Whew, how do we start? This is quite a hefty one. How can we tackle this question? It feels like we need to do some sort of substitution. And also, my gut instinct is that we are going to separate the integral from the left-hand side. So we are going to split up into two parts. First part with going from minus a to 0. And the second part going from 0 to a. And I'm thinking of doing this because we need to make use of the substitution that we are given. So, why don't we use a substitution here? Let's say u is equal to minus x. Why did I think of this? One, because we need to get the integral from 0 to a. We have negative a, so that's not nice. Two, we are also given information about f of x. Notably, f of x is an odd function, so we would better make use of that somewhere. So if u is equal to negative x, du is equal to minus dx. Integral becomes from a to 0, f of minus u, ln of 1 plus e to the minus u, minus du, plus the second integral. Where do we go from here? With a minus, we have f of negative u. So this is nothing more than f of u, because that's what we're given. We'll need to do a bit of manipulation first before we can add the two integrals. The bounds here are from 0 to a. So let's swap the order of integration. Let's swap the order of the bounds to go from 0 to a. So that means we have to take the minus sign out. What else can we do? We can now combine the two integrals. Notice that even though the first integral is in terms of u, we're integrating with respect to u. So the first integral is no different from this guy. We can replace every instance of u with x. Now we are going to combine the two integrals. This is arguably the hardest part of the entire question. Let's multiply and divide the second integral, the second term by e to the x. Now, this seems a little radical, but noticing that this is the same thing as that, we can now use laws of logarithms to simplify the question, to simplify the integral. They cancel out, ln of e to the x, that's x, and therefore we have arrived at our final answer. This is quite a challenging question. But nope, we're not done yet. Part D. Okay, so look at the left hand side. We have an integral from negative pi by 4 to pi by 4. We have a function multiplied by ln of 1 plus e to the x. This is also located right after part C, so we know we need to use part C somehow. This part will become x if we use the result from part C. Notably, this integral, if we can use the result from part C, is equal to this integral here. Correct? And also notice that sine of 2x is a multiple of the derivative of the denominator. That means that we can integrate the trigonometric term using a u substitution and hopefully make use of part B. So what is our game plan for this question? 1. Show that this function is odd, aka we can actually use the result from part C. B. Integrate by parts. So first off, let f of x be this guy. We need to show that f is odd. So we'll consider f of negative x. Be prepared to use symmetry of trig functions over here. So quickly sketch out the graph of y equals to sine of x. We know that it is odd. Sketch the graph of y equals to cos of x. We know that it is even. Thus, this is negative f of x, therefore f is odd. F is also continuous because 2 plus cos of 2x can never be 0. You don't need to prove it explicitly, but I think it would suffice to mention that it is continuous. Therefore, we can use part C. Using part C, we arrived at 0 to pi by 4 sine of 2x divided by this guy squared times x dx. This is screaming for integrations by parts. So if u is x, dv is this shenanigan, du is dx, and v is going to be this integral. You are more than welcome to make a substitution on the side. I know that it's tempting to do a u sub, but remember, we have already used u here, so please use a different variable. T, for instance. Therefore, this integral becomes this, and now we just have to integrate. The integral that we are asked to evaluate is equal to u times v we can plug in the bounds minus the integral of v du. Upper bound, cos of pi by 2, that is 0. Second integral. This looks familiar. Have we seen this before? 1 over 2 plus cos of 2x. What's this? So what we are going to do is we are going to take this value and we are going to bring it down here. After factoring out the 1 by 2, of course. And thus your final answer is, and this concludes the question.